Okay, this is ACP Geometry Summer Packet, page 6, problem number 39. Okay, this is factoring with coefficient to the first term. So I think most of you learned it this way, that you do 3p and then p, and then this is -5, so the only factor is 5 and 1, so you do like this, and +1, and see if it works, and then if not, then change the signs and try it. So in this case, this is positive, so only option is either -5 and 1, or +5 and -1, or -1 and 5, or +1 and -5, right? So those are the four options, and then you are foiling it out and then see if you get -2 in the middle. So I'm totally fine with you doing it that way. I just don't like trial and error, because on the test, when the first couple doesn't work out, I get very frustrated and then get stressed out. So I show you another way to do this, that you don't have to do a trial and error. Now, if you find this confusing, don't do it this way. Do the way that you know. Okay, I'm totally fine with you doing the way that you do it. Okay, so here is my way. And there is actually a whole video of factoring that's showing a lot of problems with my method. So it's called a factoring demo. So if you want to look at them, you are welcome to. So you look for the factors in these first and last terms. You have 3 and 1 here, and then 1 and 5. Okay, so that means, and then this is negative. So you're looking for the two numbers whose difference is 2. And this is -2. So that means it's -5 and +3. Okay, so this is 5 and 3. You're looking for two numbers that you can use these factors whose difference is -2. So now you're going to rewrite this. The 3p squared minus 5p plus 3p minus 5 equals 0. I just rewrote this -2p into -5p and +3p. Okay, together this is -2p, which is the same. So these two equations are the same. Now you factor by grouping. So from this term and this term, you have 3p in common. So you can factor 3p out, and from this term you have p left, and from this term you have 1 left, right? If you distribute this, you get 3p squared plus 3p. And from this term and this term, you have -5 in common. So you have -5, and what's left is p plus 1, right? If you distribute this, you get -5p minus 5. -5p minus 5. This is equal to 0. Okay? Now, the p plus 1 is a common factor of these two terms. So you can factor that out. P plus 1, and what's left is 3p minus 5 equals 0. And you have to solve each quadratic by factoring. Okay, so that means either this is 0 or this is 0. So you have to set p plus 1 equals 0, then p is minus 1, or 3p minus 5 equals 0. So 3p have to be equal 5. That means p have to equal 5 over 3. And those are the two answers for this quadratic equation. Okay, all right, so I'm actually going to do this one too. Okay, and in the same method. So 7 is 7 and 1. This is 2 and 2 and 14 and 2. So 2 and 2 and 7, right? If you multiply 4 plus 7 is 28. Okay, so now we are looking for the combination of these two numbers. This is plus, and then this is positive. We are looking for two positive numbers that add up to 53 using these numbers, and that will be 49 and 4. Okay, so you rewrite this: 7x squared plus 49x plus 4x plus 28 equals 0. Okay, so 49 plus 4 is 53. These two equations are the same. Now you factor by grouping. So 7x, and what's left is x plus 7. 7x, this is 7x times 7 is 49x, right? And then here you can factor 4 out. So 4, and what's left is x plus 7 equals 0. Now these are the common factors of these two terms, so you can factor that out. X plus 7, and what's left is 7x plus 4 equals 0. The factoring is done. There is no trial and error involved. You get straight to the answer. So x is negative 7, and 7x. So for this one, x is negative 7. And for this one, 7x plus 4 have to equal 0. So 7x have to equal negative 4. That means x is negative 4 over 7. So that's the other answer.